Hello friends. So today we are going to learn the part programming, axis motion and its nomenclature in manufacturing unit number 2. Myself Mr. S.P. Udgave, Department of Mechanical Engineering, working as an assistant professor in Sharad Institute of Technology, College of Engineering, Hyderabad. The learning objectives to understand the part programming and second to know the fundamental elements for developing manual programming. Learning outcomes, students should be able to explain about the part programming and able to aware about manual programming. From drawing to the workpiece, the first step it is a reading drawing. Second step, after reading the drawing, that part we can generate the programming with G code or M code. Then putting that program in the machine, that is with controller, and then by using that machine CNC, NC or the different computer control machines, we can manufacture the product. So these are the steps, basic steps we are going to follow to manufacture any product, with the first reading the drawing, which dimensions and the tolerances provided, and the required, that is a programming we generate as per the machine type. The G code, M code we can use to generate the program, and we can feed that program to the controller, through the controller to the machine, and with first try, that is a we can check the that is a correct run or not, and then after that, after trial, successful trial, we can continue with the manufacturing the product. Next, that is a part programming. They are classified into the numerical control or computer numerical control, CNC. The part programming is the sequence of instructions which describe the work which has to be done on a part in the form of required computer under control of numerical control computer program. It is a task of preparing a program sheet from drawing sheet. All data is fed into the numerical control system using standardized format. The machining data is as follows: the machining sequence classification of processes and tool startup point, and we can provide cutting depth and tool path. Second stage, that is a cutting conditions, spindle speed, feed rate and coolant on off we can specify, and finally that is a selection of the cutting tools. The steps of part programming: this, first the study component drawing, then second step, identify the machine tool with the help of machine tool database, then we select the cutting tools with machine tool database, depends on the type of selection of machine, specific tools, cutting tools we select. Next step, determine the machining parameters, the parameters which are required to machine, that is a drilling, milling or the different operation in milling operations, that is determine the machining parameters, that is a machining tool database, and then we prepare the job and tool setup plans as per the required of that part, and write part program. We can test that part program. If it is okay or correct, then we can use the machine control in it. If it is not okay, then we again go for the determining the machining parameters, and that is a document the program. Means that is after completion of program we can document that program, and that if it is okay we can provide to that program to the machine through the controller in it, and machine it is run. Trial run first we can take, and inspection of the part it is done. If it is okay, then we can go for production. Now the first, that is determining the startup procedure, which includes the extraction of dimensional data from part drawing, and data regarding the surface quality requirements on the machined component. That is done in first, that is a study of component drawing. Second, select the tool and determine the tool offset from machine that is a machine coordinate system, and component or part that is placed on the table, that coordinate system are different, those, so we can select the tool offset. Next, set up zero position for workpiece. Next step, that is the setup of tool motion according to the profile required. Selecting the speed and rotation of the spindle. Then the return the cutting tool to the reference point after completion of work. And finally end the program by stopping the spindle and the coolant. These are the steps we can follow to complete the program. Now the fundamentals elements for developing part programming, in which the first one is the part programming consists of sequence of instruction to be performed in numerical control, that is a NC, and computer numerical control machine, CNC. These are two types, manual part programming and the second one computer aided part programming, CNC. In order to prepare part programming, the programmer decides the order of the machining operations that is required to produce component. Then the choice of machine tools and cutting tools depends upon the operation. After completion of that, each line program is numbered in sequence and details of operations are stated and X, Y, Z coordinates are given. Fundamental elements for developing part program. First one, that is a knowledge about various manufacturing process and machines that is required for developing the program, and then sequence of operations to be performed for a given component, because the numbers of operation, all operation we cannot complete on the single machine. So we know the knowledge of all the machines and their program, and which operation it is done on which machine, that initially we can specify, and the sequence of operation we can perform, that is depend on the given component. Next, knowledge of selection of the cutting parameters. We can select the cutting parameters, they vary as per their operations, and then editing the part program according to the design changes. And finally, that is a knowledge about the codes and functions used in part program. So these are the fundamentals elements that is used for developing the part program. Then manual part programming. The first, that is the programmer prepare the part program manuscript in standard format. Then that manuscript are typed with the device known as a flexowriter, which is also used to type the program instruction, and the complex shaped components are required the tedious calculations. This type of programming is carried out for simple machining parts produced on point-to-point machine. Second, computer aided part programming. If the complex shaped components requires, that is a calculations to produce the component are done by programming software contained in the computer. We can use the Telcam or particularly specifically softwares. Those are available in market, and Fusion 360 or numbers of softwares are available. Those we can use and we can generate the program for the complex component. So similar, there are various programming languages are developed in the recent past, such as APT, automatically programmed tools, adapt, autospot, compat, and the 2CL romance split is used to writing the computer program which has a English like statements, and translator, that is known as the compiler program, is used to translate it in form acceptable to machine controlling it. Then the machine coordinate system or axis motion nomenclature, that is the direction of each finger, that is the right hand rule. We can use the direction of the each finger, that is represents the positive direction motion x, y, z. The axis of the main spindle is always z, and the positive direction is into the spindle. On a mill, the longest travel slide is the designated by the x-axis and always perpendicular to the z-axis. If you rotate your hand looking into your middle finger, and the forefinger represents the y-axis. Now the base of your fingers is, this is the base of your fingers, that is the start point x0, y0 and z0. That is a machine coordinate system. Then rotary motion, the right hand rule for determining the correct axis on CNC machine may also be used to determine the clockwise rotary motion about x, y, z. To determine the positive or clockwise direction about axis, close your hand. We are closing our hand and with thumb pointing out, and the thumb may be represent the x, y, z direction, and the curl fingers, that is represents the clockwise or positive rotation of each axis. These are known as a ABC. So direction of rotation, that is we can represent with the ABC, and represent the rotary motion about x, y, z respectively. The next, that is a axis and motion nomenclature for CNC coordinate system. We can see through the animation. Now for the regular 2D plane, in Cartesian coordinate system we can see only two axes, that is the x and y. We cannot see the z axis, that is a 2D plane. And for 3 axis and third axis, that is we can see in isometric, that is with right hand rule, right hand thumb rule, that is shown. Thumb it is a represent, and forefinger and middle finger, these are the shown. And x direction, it is with the red color, with finger, that is a thumb, y axis, forefinger, and middle finger, that is represent the z axis. Now first find the z, that is a look for the spindle. This is a spindle, that is shows the z direction, and this is the positive rotation about we can move the four other fingers, that is a moves, or that is a curl, we can take fold, that is shows the direction, and the table on which, that is a perpendicular and long length, that is a with shade with 90-degree angle, we can represent the, this is the table with the z, that is perpendicular x-axis, and towards that for both in 90-degree remaining is the y-axis. Then the types of coordinate systems are two types of coordinate systems. The first one is the program coordinate system related with the table, and machine coordinate system. Machine coordinate system that is related with the spindle, and program coordinate system that is related with the component that is placed on the table. The offset coordinate system offset in between the spindle and the component or the table having the offset, that is x and y offset, that is distance between the from the vertical z axis, that is of program coordinate system, and vertical axis of machine. In that is a space, it is called as a offset. Now offset are stored in controller through the part programming, that is a part 0 we can set through the controller by this button, and in which that is initially G54 represent the x and y, that is a program, that is a coordinate system or product coordinate system, with same G55, G56, and remaining are we can represent for the product for the location. So related with the program coordinate system, from the G54 represent, that is related with the first component, and similar way the second component when we mount on the table. So first component that is related with the program coordinate system G54, and second that is a G55 we can represent with relative with the machine coordinate system. That is related with the stationary component and rotary, that is a spindle. We can represent this system for the CNC coordinate system. Now for the rotary table, when we mount the particular rotary chuck on the table, at that time that is defining the x, y, z coordinates and the rotation with the rotary axis, that is A is the rotation of around the x-axis, B is the rotation around the y-axis, and C is the rotation around the z-axis. These are shows the positive. And another right hand rule with the, we can take the thumb with the plus direction, y direction we can show, and with that curl fingers are shows the direction, positive direction rotation, that is a B. Similar way we can represent for the x-axis also. We can take the thumb for the x-axis and the curl fingers that shows the positive direction of rotation. Similar for the z-axis. So rotary axis, that is a represent for the x with the positive direction, and curl fingers, that is right hand rule we can use, and that is a plus rotation about the axis. So these are the axis and motion nomenclature we see in this video, and next video, that is a basic structure we can study for programming. So thank you and stay connected for the next video.